Hello everyone, this is Nick McCullum, back with you again for another Fast Track for Azure End of Life Learn session, where today's topic is Classic Cloud Services to Cloud Services Extended Support Migration. A Learn collection has been created, including documentation and samples, to support you in your migration efforts. In this session, we will review the options for migrating a classic cloud service, specifically web and worker roles, to Cloud Services Extended Support. So why should you upgrade to this new Cloud Services Extended Support? Azure Cloud Services Classic will be retiring on August 31st, 2024. Prior to that date, you'll need to migrate your services that were deployed using this model to Cloud Services Extended Support in Azure Resource Manager. After August 31st, 2024, Classic Cloud Services will no longer be supported, and the applications running on them will no longer be available. Upgrading to this new model provides you some significant benefits. You get support for deployment templates using ARM, role-based access control, and regional resiliency. A little bit of background on Cloud Services Extended Support. Cloud Services Extended Support was designed to run in the Azure Resource Manager and allows you to use your existing web and worker programming model without making changes to your existing application code. There will be some minor configuration changes that we will discuss during this session. This session is intended for customers who have existing classic cloud services, web and worker roles that must be migrated to Cloud Services Extended Support before the deadline of August 31st, 2024. There are two migration options that you can choose from to migrate your applications from Cloud Services Classic to Cloud Services Extended Support. This includes an automated migration feature, or you can choose to redeploy your web and worker roles to a new Cloud Services Extended Support instance. The automated migration feature enables a seamless platform orchestrated migration of existing Cloud Services Classic deployments to Cloud Services Extended Support. It's important to note that the public IP address on the cloud service deployment remains the same after migration to Azure Resource Manager and is exposed as a basic SKU IP, either dynamic or static, depending on the definition of the original IP resource. The DNS name and domain, cloudapp.net, for the migrated cloud service also remains the same. This means there should be no impact on any existing DNS or firewall rules that were associated with your classic cloud services following the migration. To begin the migration, open up your classic cloud service in the Azure portal. You should see a reminder that Cloud Services Classic is being deprecated and will retire on August 31st, 2024. Navigate to the Migrate to ARM blade using the left-hand menu. If the Classic Cloud Services deployed to a Classic virtual network, the migration tool will require that it examine the virtual network to ensure that it can be migrated to ARM along with your Classic Cloud service. In my case, my cloud service is in a Classic virtual network, so I'll select this option. Click the Validate button to begin the migration. The migration tool will validate that the migration will not be prevented by common unsupported scenarios. If the validation is successful, then all deployments are supported and ready to be prepared. If the validation fails, a list of unsupported scenarios will be displayed and need to be fixed before migration can continue. In my case, the validation has passed, and my virtual network and my classic cloud service will be migrated. At this point, I'm going to select the Prepare option. During the Prepare phase, the migration tool is going to duplicate the resource metadata for the classic resources in Azure Resource Manager. All the resources are locked for create, update, delete operations to ensure that resource metadata is in sync across the Azure Service Manager and Azure Resource Manager. All read operations will work using both Classic Cloud Services and Cloud Services Extended Support APIs. The prepare phase can take anywhere between 15 and 20 minutes, depending on the resources being migrated. If the prepare phase is successful, the migration is ready for commit. All cloud services in the virtual network are available for read operations using both Cloud Services Classic and Cloud Services Extended Support Azure Portal Blades. The Cloud Service Extended Support deployment can now be tested to ensure proper functioning before finalizing the migration. If the prepare fails, review the error, address any issues, and then retry the prepare. Refer to the unsupported scenarios and common migration errors documentation. After roughly 15 minutes, my prepare operation has completed, and you'll notice I've been provided a link to a new resource group in Azure Resource Manager that has all of the migrated resources. I can go examine the resources in that resource group, and you'll notice that I have a new IP address that was created. Again, this is a basic SKU IP, a key vault, which is created in case you had any certificates that were associated with your classic cloud service. Those certificates are now moved into a key vault. I have a load balancer for the cloud service, and then I have my cloud service itself, which is now available as a Cloud Services Extended Support instance. Since my prepare is successful, you'll notice that I now have an option to either commit or abort the migration. Once you have had an opportunity to examine the resources that were migrated to the Azure Resource Manager, if you are satisfied, you can type yes to confirm the migration and click the commit button. Once the commit has finished, the migration is complete and the Cloud Services Extended Support instance is unlocked for all operations. The classic cloud service and its associated resources will be removed. If for some reason you're unsatisfied with the migration and you wish to discontinue, you can click the abort button to roll back the previous steps. Once the abort finishes, the classic cloud service instance is unlocked for all operations. In my case, I'm satisfied with the migration, and I'm going to click yes to confirm the migration, and then select commit. The commit, again, is going to take several minutes to complete, but once finished, your resources should be available and ready for use in the Cloud Services Extended Support instance. Once the commit phase has completed, you should receive a notification that the migration is successful. I can now go to the new Cloud Services Extended Support instance. I should be able to open the URL for my cloud service, and if I have a web role deployed there, my application should launch in the browser. As you can see here, I have just a simple ASP.NET application, and you'll see Cloud Service Sample Web Role. So my migration was successful. All my resources, including both the virtual network and the associated classic cloud service, have been migrated to the Azure Resource Manager. And if we navigate back to the classic cloud services, we should see that that demo cloud service has been removed. And I only have one remaining here. I originally had two. So our migration using the automated migration tool has been successful. And now we will talk about what if you just want to basically redeploy your existing application to a brand new Cloud Services Extended Support instance. Before we move on to discussing how to take your existing solution and redeploy it to a new Cloud Services Extended Support instance, I just want to touch on three of the common issues that we tend to see when working with customers on these classic cloud service migrations. And the first one tends to be very common, which is invalid SKU sizes. So you go to run your migration, you get through the validate, and you get into the prepare phase, and it kicks back with an issue saying your service definition has invalid SKU sizes. And that's because many of the older cloud services deployments in Azure use the original t-shirt size SKUs that we had for the A-series virtual machines. So extra small, small, medium, large, and extra large to define their compute requirements. But these SKU sizes are not supported by Cloud Services Extended Support. And before you can complete the migration, you actually have to update these and move on to a supported SKU size before you can execute the migration. So to correct this issue, what you're going to do is go into Visual Studio. You're going to open up your service definition.csdef file. And for each of your web and worker roles, you're going to go to this VM size property here and change this. If it has one of these t-shirt size SKUs, you're going to change this to one of these supported SKU sizes that are listed in the documentation. Then you're going to have to repackage and then redeploy your solution to your current classic cloud service. Once you do that and you're on a supported SKU size, then you should be able to go back and re-execute the prepare phase of the migration, and everything should be good at that point, and you can continue on with your migration effort. So be aware of that. The second one we see quite often is the whole issue with stage deployment. So one of the great things about Classic Cloud Services is we supported the deployment slot feature, which is also available in our other products like the Azure App Service, where you had a production slot, which is hosting your production code, but then you also had kind of a staging slot where you could deploy your new code, verify that everything was there and ready to go, and then you could do what we referred to as a slot swap to move that new code then into production, and the old code went back into the staging slot. The migration tool cannot operate if you've got both slots populated with a deployment. So you've got a production deployment, and you've also got a staging deployment in the staging slot. You're going to get an error about that when you're doing this. So what we want to do then is actually go over to the Azure portal, and let's go ahead, and I've got a classic cloud service out here that actually has a staging slot on it that's got a deployment in it. And if you'll notice at the top here, when you're on the overview blade, it tells you which slot you're currently in. Usually this defaults to production. So this is my production deployment right here. But if I pull this down, you'll see there's also this staging slot. And if I switch to this, you can see I've got a deployment here as well. All right. And the important thing to note is if I tried to execute the migration at this point, it's going to tell me right away during the validation phase that this scenario is not supported. I cannot have a production slot and a staging slot, both of them occupied with a current deployment package. So what I've got to do here in order to get around that is go to the staging slot, select the delete, and that's going to delete the deployment from the staging slot, and then the staging slot is going to be empty after that. Once I've deleted that deployment from the staging slot, I can go ahead, go back to the migrate to ARM blade, select validate again, and then I'll be able to continue on with my migration. The last one is a little bit of something, we do see this, but it's not seen as often. It really just depends on how old the classic cloud service deployment is that you're trying to migrate. While many people aren't aware of this, when you deploy a classic cloud service, behind the scenes, the Azure Service Manager, if you're not deploying your cloud service into a virtual network, he behind the scenes creates a default virtual network for that cloud service, because every cloud service has to be deployed into a virtual network. Even if you're not specifically deploying it there and managing that VNet, the Azure Service Manager creates one for that cloud service. The only time this didn't happen is on the very first iteration of classic cloud services. So if you have a very old cloud service, it may not have a default virtual network associated with it. And this again is a scenario that the automated migration tool cannot handle automatically for you. So you're going to get an error that basically says, hey, I can't migrate this cloud service. It doesn't have a virtual network associated with it. So the way you can rectify this, and it's kind of built on something that we just talked about, which is stage deployments, is you can basically go out, take your existing production deployment package, the one you use to deploy to your production slot. You can redeploy that, empty out your staging slot first. So go to your staging slot, just like I just showed a few minutes ago, and delete the deployment that's currently there. So the staging slot is completely empty. There's nothing in it. Then take your existing production deployment package, whatever that last package that you use to deploy to your production slot, and deploy that to your staging slot. When you do that, there's some changes that have been made to basically check to see if that cloud service was associated with a virtual network or not. And if it didn't have a default virtual network associated with it, when you deploy that package to the staging slot, a default virtual network will be created, a classic virtual network. It will be then bound to the cloud service deployment that's in the staging slot. All right. So at that point, what you'll have is a production slot that's running your production code, not bound to a virtual network, a default virtual network. You'll also have the staging slot running the exact same code as your production slot, but this one will be bound to that default virtual network that was created for it behind the scenes. Once you have that in place, all you have to do is basically jump back over to the Azure portal and do a swap between the staging slot and the production slot. All right. So at that point, what will happen is the staging slot that has the production code that's bound to this default virtual network will become the production deployment, the production slot. And it will be all set and ready to go. The old production code or the old production slot becomes the staging slot. It's not bound to the virtual network, but that's okay because we have to delete that staging slot anyway before we attempt the automated migration. All right. So delete that staging slot once you've done the swap, go back to the migrate to ArmBlade, and you should be okay to continue with the migration because now your production slot has that default virtual network bound to it that the automation migration tool requires. So again, just wanted to touch on three of those errors that we tend to see when we're working with customers. And now we'll move on and talk about how to redeploy if you want to an empty or a brand new cloud services extended support instance. If you cannot use the automated migration feature to migrate your classic cloud service to cloud services extended support, or you would like to perform a manual migration, you can redeploy your cloud services to a new cloud services extended support instance. Cloud services extended support supports both web and worker roles, and no changes are required to the design, architecture, or components of your web or worker roles. And no changes are required to the runtime code as the data plane is the same as classic cloud services. Prior to redeploying your services to a cloud services extended support instance, please be aware of the following configuration changes. Cloud services extended support must be deployed to a virtual network. So make sure to update your service configuration.cloud.csconfig file to include a network configuration section with a virtual network site entry pointing at the name of the virtual network you plan to deploy to. And make sure to include an address assignment section with entries for each role specifying the subnet within the virtual network. So let me jump over to Visual Studio here real quick and just take a look at this. So here is the network configuration section of my service configuration.cloud.csconfig file. And you'll notice I have a virtual network site here. Now this is a classic virtual network definition. And this is one of the differences between classic cloud services and cloud services extended support. So previously when we specified the virtual network name, we had the keyword group followed by the name of the resource group that contained the virtual network, then a space, and then the name of the VNet. And then down here in the subnets under the instance address, in the address assignments, we'd have the name of the subnet where we wanted that role deployed to within the virtual network. When we change to cloud services extended support, if the virtual network is in the same resource group as the cloud service, then the name in the virtual network site entry is just the name of the virtual network, right? We don't have to do the resource group or anything like that any longer, just the name of the virtual network, as long as it's in the same resource group where the cloud service is at. If it's in a different resource group, all right, then we're going to jump over, and what we need to do is go to the Azure portal real quick and look at the properties of the virtual network So here I've got my virtual network up and I've got the properties blade open, and I have to have the full resource ID down here. All right, so if this is this virtual network, we're in a different resource group than the cloud service, then instead of putting just the virtual network name in that entry in my service configuration file, I would go ahead and put this full resource ID here where I've got just the virtual network name now, right? So again, same resource group, I can just get away with just using the VNet name. If it's in a different resource group than my cloud service, then I'm going to put the full Azure resource ID of that VNet in the name field. All right. And then again, in the instance address under the address assignments for the subnet, I'll put the name of the subnet where this particular role is going to be deployed to, right? So just keep that in mind. A couple other things to be aware of in regards to changes to the service configuration file. If you're defining specific public IP resources as IP input endpoints in the service definition file, the CSDEF file, then make sure that you specify a public IP address resource. You have to create one of those or multiples depending on how many IP input endpoints you have in Azure. And again, remember that Cloud Services Extended Support only supports the basic IP address SKU, right? So you have to create those IP address resources in Azure. If your service configuration file, the csconfig file, says that that IP address is a reserved IP address, then you have to make sure the allocation type for the public IP resource that you create in Azure is set up as a static resource, a static IP address, and not a dynamic IP address. All right. If you have one or more certificates in your service configuration file. Um, Maybe you're using one to set up SSL for a web role or something like that. You have to make sure that you set up a key vault for that cloud service extended support instance. We've seen that one was set up automatically when we used the automated migration tool. And then you have to upload all those certificates that are specified in the service configuration file to the key vault. Now, one thing we've seen customers run into with this, if you are using self-signed certificates, Key Vault only supports RSA keys with a minimum of 2048 bits. If you're generating self-signed certs that only have 1024-bit RSA keys, then you're going to need to recreate them prior to uploading them to Key Vault and make sure they've got 2048 bits. All right, so be aware of that. So again, once you've made those configuration changes, there are detailed instructions in all of our docs on how to then redeploy your cloud service using the portal, PowerShell, ARM templates, the SDK or Visual Studio. If you go ahead and let me quickly jump over back to the Azure portal here real quick, and let's just take a look at the blade to create a new Cloud Services Extended Support instance. One of the things you're going to notice that's a bit different from classic cloud services is when I go to create this cloud service, and it doesn't matter whether I'm doing this via the portal or an ARM template or whichever mechanism, you'll notice that I have to provide the CS package file, so my deployment package, the CS configuration file, and the CSDEF, the service definition file, right here immediately when the cloud service is created. In classic cloud services, we could create an empty cloud service and then deploy a package to it later. The concept of empty cloud services does not exist in cloud services extended support. So when you create a cloud service, you have to have your package file ready to go and your CS configuration file and your CS definition file, which is why I mentioned a few moments ago, making sure that you've got your virtual network created, you know the name of the VNet, you know the name of the subnet that you're going to be deploying to, you've got your public IP addresses defined all within these configurations, because when you go to this next tab here, it's going to want to know, okay, where's your VNet at? Which subnet are you deploying to? Do you have any public IPs? What's the key vault, right? And all those things have to be in sync with the information that you've provided in the service configuration file and the service definition file. So it's important, again, you set the appropriate resources up in Azure first, your virtual network, your key vault, any public IP addresses that you need. Make sure that information is set up correctly as well in the corresponding configuration files, so that when you go ahead to create your cloud service extended support instance, all the files are correct, all the resources are there, and you can proceed either through this blade or via ARM template or PowerShell to create this cloud service and update and upload that first deployment package to it as part of that setup. All right. So again, that's kind of the process for the redeploy. Again, there's not a lot of change here with the outside exception of, again, making sure you've got your configuration file set up and that when you go to create your cloud service, all the supporting resources have been created and you've got your package file and your configuration files ready to go. All right. So we'll go ahead and talk about, once you either use the automated migration tool or you redeploy, some of the post-migration changes that you might have to deal with once you kind of have everything up and running and you're past that initial migration phase. So regardless of whether you've used the automated migration feature or you've decided to do a redeploy of your existing solution to a new cloud services extended support instance, there are some post-migration changes that you'll need to make. The automated migration feature will make minor changes to the CSDef and CSconfig files to make the deployments conform to the Azure Resource Manager and Cloud Services Extended Support requirements. Now, when we did a redeploy, we already manually made those changes to both our CS definition file and CS configuration file so that we could create a package that was compatible with Cloud Services Extended Support before we uploaded it to that new cloud service. But in the case of the automated migration tool, we need to get those changes now and incorporate those back into our source code so that the next time we want to do a deployment, our source information is compatible with the new cloud services extended support instance that we migrated to. And I've included links in the documentation for both PowerShell and the REST API on how to download the updated service definition file and the service configuration file. Now you'll have to use those commands to get these. The service configuration file changes you can actually see in the portal. So if we jump over to the Azure portal here and look at the one that we migrated using the tool earlier, under the settings here in the menu, I can go to configuration and you'll see this is the updated CS config file. And there's even an option for me to download that here. And you'll notice it updated things like the virtual network name here to use the resource ID rather than that group space resource group name virtual network name that we used in the classic cloud service. But again, there's no way to do this for the service definition file, so you'll have to use the PowerShell or REST API to do that. Regardless of whether you chose to use the automated migration feature or the redeploy option, you still have to deal with changes to your Azure DevOps pipeline following the migration. So let's jump over into my Azure DevOps account and take a closer look at what I'm talking about here. So this is a build pipeline. I'm using the classic editor just to visualize it, so it makes it a little bit easier rather than looking at the raw YAML. But this is a build process for a cloud solution project or cloud service project, and there are no changes here. You can still use the build solution command and the build ccproj command here, and this one, of course, will generate your CS package file for deployment. So no changes from a build perspective, but when we jump into the actual release pipeline, and again, I'm going to go ahead and use the classic editor here just so that we can visualize this. If we looked at what we used to do, and let me bring up the task selector here, and I just do a search for cloud service. We used to have this Azure Cloud Service deployment task in ADO, and worked great. But this task only works for classic cloud services. It will not work for cloud services extended support. If you try to use it, it will just fail. So you're going to remove that from your pipeline, and then we're going to replace that with some PowerShell commands. So The first thing we're going to do here is we're going to take the CS package file that was produced by the build and put in the artifacts folder, and we're going to upload that to a storage account. So I'm uploading it to a container called PS deploy. Once I have that CS package file in my storage account, then I'm going to run this PowerShell command. And basically the PowerShell command is going to get a SAS URL for the CS package file that we uploaded to storage. And then it's going to go ahead and retrieve the service configuration file from the artifacts directory. And then it's going to retrieve the actual definition of the current cloud service. And then it's going to set the configuration on that cloud service definition to the contents of the CS config file that we basically piped into a string here. And then it's going to set the package URL to that new SAS URL that we retrieved for the updated package file that was in our storage account. And then it's going to pipe that to an update AZ cloud service command. So let me switch over to the PowerShell editor just so we can take a deeper look at the PowerShell code. So here in PowerShell, like I said, we're retrieving the storage account. We're basically uploading the contents of the CS package file to a container in that storage account, and then we're retrieving the SAS token for that uploaded blob. Getting the contents of the configuration file, the CS config file, piping that to a string, retrieving the definition of the current cloud service that's out in Azure, and then updating the configuration property with the new configuration values, and then updating the package URL to point at the package that we uploaded to the storage account. And then we use the update AZ cloud service PowerShell commandlet to actually trigger the deployment on the cloud service. So not very complicated, but definitely a change from what we had before using just the simple deploy cloud service task that we had for Azure DevOps. So that's the changes from the pipeline perspective. And again, the sample PowerShell script, a Word document containing the steps for the classic release pipeline, and then a sample YAML pipeline have all been put in the GitHub repository that I've got linked to the documentation, so you can pull those samples from there. And then we already mentioned this earlier, but I want to go a little bit more in depth on the changes to a staged deployment. So classic cloud services, we had the deployment slot feature, worked great. Cloud services extended support, that concept has been replaced with this new idea of a paired set of swappable cloud service extended support instances. So the process now kind of goes like this. You deploy your updated solution package to the new cloud service extended support instance, and you indicate that this new cloud service is swappable with an existing cloud service that you've already deployed that's hosting your production code. So you can do this via the portal. It's also available via ARM templates, as I've mentioned here. But if we come back and look at the second step in the create a cloud service blade here in Azure, you'll notice on this configuration tab, there is a property for a swappable cloud service here. So I can pick my partner that's going to be joined with this cloud service that I'm creating, and then the two form a swap pair that I can then use to basically deploy code to one and then swap it with the other one once I've had the opportunity to verify that. So we've got samples again in the repo that cover both the pipeline in classic format as well as a YAML pipeline on how to do this. So let's take a quick look at that. And I'm going to jump back to that release pipeline here and go to the swap. And I'm going to edit this guy. And again, you know, we've got two stages, and the first one is deploy to our staging environment, and then the second one is then swap that with the production cloud service that's running the current code. So, and if we take a look at this, it looks really similar to what we just walked through. I've got a file copy to move the new package that was created by the build up to a storage account. And then we've got a script again, and this script is slightly different from the other one. And the key to this is we have to be able to consistently identify which of the two cloud services is the staging service at the time so that we know where to deploy the code to. And so the way I've handled this, if we jump back here to my cloud services, you'll see I've got a CSES blue and a CSES green. These two are paired together. If I take a look at blue, we'll notice that the load balancer IP address that's attached to this cloud service is CSES stage. So I've used the public IP DNS name to kind of identify which one of these is staging. And if we looked at green right now, green is playing the part of production, CSES prod. Because remember, when we do the swap, it's just going to do a virtual IP swap. So it's just kind of switching the back-end deployments between the load balancers. So what's going to happen when I do the swap is blue then is going to be basically serving as the back end for this public IP and the load balancer that's associated with it. And then green is going to be switched over to be the back end for the staging load balancer and the DNS name that's associated with it. So I take advantage of that in my PowerShell script here by retrieving both of the cloud service definitions. So I grab cloud service 1 and 2. So I've got the names here as variables. So I pull down blue and green. And then what I do is I retrieve the load balancer information for each of those cloud services. And I take a look at the DNS name that's associated with the IP address to see which one contains the word stage. And then I know that that's my staging cloud service. And I basically assign that to the cloud service variable that we're going to update as part of the deployment. And then from this point on, the rest of this looks very similar to the deployment script that we looked at earlier, where we're just basically retrieving the new package from storage. We're getting the contents of the service configuration file and piping that to a string. And then we're basically doing an update on the cloud service here with the new configuration and the new package URL. So that gets our new code to the instance of the cloud service that's acting as the staging environment. And then if we go back to the pipeline here and look at the next step in the pipeline, or the next stage in the pipeline, there's just a very simple PowerShell script here that just does a switch AZ cloud service, which is basically the command we provide to do a swap. Very straightforward, nothing really complicated about that. Once we've kind of done the deployment, the swap is a fairly straightforward thing. So before we wrap up on this, I just want to talk about some considerations when we're talking about stage deployment. So unlike classic cloud services extended support does not support a stopped and deallocated state. So in classic cloud services, because we could have an empty cloud service, we had this state where you could stop and deallocate, meaning you released all the role instances, all the resources that were associated with those role instances, and you basically weren't being billed anything for that cloud service. With cloud services extended support, we only have a stopped state. There's no deallocated state. So even if you stop all those role instances or stop the cloud service in cloud services extended support, you're still being billed for all those role instances. So it's important to be aware of that. So even if you place the quote staging instance in a stop state following a deploy and a swap operation, you're still being billed for those role instances. So the only way to avoid these charges is to delete the staging cloud service entirely following a deploy and a swap operation. But what this also means is you have to recreate a staging cloud service extended support instance each time you perform a new deployment. And this can lead to increased deployment time due to the length of time it can take to create a new CSES instance. So when performing stage deployments with CSES, you really have two options to consider. One, create that new staging service on each deployment, and then delete that staging cloud service following your deploy and swap. And then the drawback, like I mentioned, is that this is going to take a little bit longer because of the amount of time it's going to take to recreate that new staging cloud service instance each time. Option two is create your staging cloud service once on your first deployment and leave it running. And then deployment times will be much faster, but you'll be charged for the role instances associated with that staging cloud service, even if you stop them. So to reduce these costs, what you can do is scale down the number of role instances to a minimum between deployments on the staging cloud service. And the sample classic release pipeline that we just looked at, and again, I've got a YAML sample as well for using this approach, the number 2 approach, can be found in the repo that's linked to the resources. So as I mentioned earlier, we have a number of materials that are available that are associated with this Learn video that are available to you to assist with your migration from Classic Cloud Services to Cloud Services Extended Support. So here I've listed the session materials that are associated with the video, and then as well as the GitHub repos that contain the samples that we looked at for our ADO pipelines that we discussed earlier. So in summary, remember that after August 31st of 2024, Classic Cloud Services will no longer be supported, and the applications running on them will no longer be available. We've provided 2 options to assist you in migrating your Classic Cloud Services to Cloud Services Extended Support: the automated migration feature, and then you have the option to redeploy your services to a new Cloud Services Extended Support instance if you choose to do a manual migration. And again, I've listed several resources here. These are the documentation links to the official docs on how to perform the migration, and touches on some of the common errors and how to deal with those as part of your migration. So again, good luck with your migration, and if you can require any assistance, know that you can always reach out to your account team and get nominated for a fast track engagement to assist with this.